Look at a sunflower. Now look at a pine cone. Then check out a nautilus shell. What do these completely different organisms have in common? They're all following the same secret mathematical blueprint that's been hiding in plain sight for millions of years. This blueprint is called the golden ratio, and it's one of nature's most elegant tricks. The number itself is approximately 1.618, but it's not just any number. It's a proportion that shows up so frequently in nature that scientists and mathematicians have been obsessed with it for thousands of years. Here's where it gets fascinating. The golden ratio is intimately connected to something called the Fibonacci sequence. This is a series of numbers where each number is the sum of the two before it. 1, 1, 2, 3, 5, 8, 13, 21, and so on. When you divide any number in this sequence by the one before it, you get closer and closer to 1.618. The further you go, the more precise it becomes. But why should plants and sea creatures care about medieval mathematics? They don't, of course. They've simply evolved to grow in the most efficient way possible, and mathematics is just our way of describing what they're doing. Let's start with that sunflower. If you count the spirals in a sunflower's center, you'll almost always find a Fibonacci number, 34 spirals going one way, 55 going the other. Sometimes it's 55 and 89. These aren't random numbers. The sunflower is packing its seeds using golden ratio angles, specifically about 137.5 degrees between each seed. This particular angle ensures that each new seed gets maximum exposure to sunlight and rain without being shadowed by others. Think of it like parking cars in a lot. If you park them at random angles, you waste space. But if you use the perfect mathematical angle, you fit the maximum number of cars possible. Sunflowers discovered this trick millions of years before humans invented parking lots. The nautilus shell tells an equally compelling story. As the nautilus grows, it builds its shell in a logarithmic spiral. Each new chamber is proportionally larger than the last by a factor close to the golden ratio. The creature doesn't need to redesign its home as it grows. It simply adds another chamber following the same simple rule, and the beautiful spiral emerges automatically. Pine cones, pineapples, and Romanesco broccoli all display these spiraling Fibonacci patterns. Count the spirals on a pine cone, and you'll find 8 going one direction and 13 going the other. Both Fibonacci numbers. The Romanesco broccoli is particularly mind-blowing because it shows self-similarity. Each floret is a miniature version of the whole, spiraling according to the same mathematical rules at every scale. Even flower petals follow this pattern. Lilies have 3 petals, buttercups have 5, delphiniums have 8, marigolds have 13, asters have 21, and daisies often have 34, 55, or 89, all Fibonacci numbers. While there are exceptions, the pattern appears far too often to be coincidence. The reason is efficiency. Plants that grow leaves, branches, or seeds at golden ratio angles minimize overlap and maximize exposure to resources. It's natural selection favoring mathematical precision. Plants with slightly different angles got less sunlight, produced fewer seeds, and lost the evolutionary race. What's truly remarkable is that these patterns emerge from incredibly simple growth rules. A sunflower doesn't calculate angles or count spirals. It just grows each new seed at a fixed rotation from the last one. That single simple instruction repeated thousands of times creates the complex spiraling pattern we observe. This principle extends beyond plants, galaxy spirals, hurricane formations, and even the proportions of the human body show relationships to the golden ratio. The universe seems to have a preference for this particular number. The ancient Greeks discovered the golden ratio in geometry and considered it aesthetically perfect. The Parthenon's dimensions reflect it. Renaissance artists like Leonardo da Vinci used it in their compositions. But nature was using it billions of years before humans existed. Here's a fun challenge. Next time you're in a garden or grocery store, start counting petals and spirals. You'll be amazed how often Fibonacci numbers appear. That pineapple has 8 spirals one way and 13 the other. Those succulent leaves spiral in patterns of 5 or 8. The golden ratio reveals something profound about our universe. Complex, beautiful structures don't require complex instructions. They emerge naturally from simple mathematical rules repeated over time. A single angle, one growth pattern, millions of iterations, and suddenly you have the intricate beauty of a nautilus shell or the perfect packing of a sunflower. So the next time someone tells you that math isn't natural or relevant to the real world, hand them a pine cone and ask them to count the spirals. Nature's been doing advanced mathematics since long before we invented calculators. What other mathematical secrets might be hiding in the world around us, waiting to be discovered?